Hello everyone, welcome to pre-algebra lecture. This is the last section of Module 6 on percents, and in this section I want to discuss just some general applications of percent. We already talked about how to solve percent problems, so now we're going to look at other types of problems, applications, word problems that involve percents. So one concept that comes up often is the idea of a percent increase or decrease. So let's begin by talking about that. So finding a percent increase or decrease. Okay, so the formula that you want to use to find a percent increase or decrease is the following. You form a ratio, right? You take the new value minus the original value. You divide that by the original value. So you have a ratio, right? You have a fraction, and then you want to convert it into a percent. So now you basically multiply by 100, right? When you have a fraction, multiply by 100 and add the percent symbol. So think of this as this is the difference divided by the original value times 100. Okay, and again, this part multiplied by 100 just converts that ratio, that fraction, to a percent. Now, because we haven't really discussed negative values yet, we will talk a lot about that in the next module. We haven't really discussed negative values yet. So another way to think about this difference is just use the positive difference. Just think of this as largest minus smallest. Okay, so you don't really have to say new minus original. You can just say the largest value minus the smallest value. Okay, and then we can figure out whether it's an increase or decrease just by what's happening with the values themselves. If they go down, it's a decrease. If they go up, it's an increase. So again, think of the difference, the numerator, as being the largest minus smallest, but it is important that you always divide by the original value and then times 100. So here, let's do some examples. Actually, I'll start off with just numbers in a table. Let's say we want to complete this table. So I'm going to give you the original value, the new value, and then we want to find the percent increase or decrease. Let's say my original value is 5. The new value is 6. Could be anything, $5, $6, whatever you want. I'll just use the regular numbers with no units. And I want to find whether it's increase or decrease and what that percent is. And then let me write down a couple more. Let's say I start at 12. My original value is 12. I go down to 10. What is that in terms of a percent increase or decrease? And then maybe 100 down to 20. Okay, so these are like 3 separate problems here. All right, so how do I solve? Let's start with the first one. Here, let me emphasize that these are like 3 separate problems, like drawing a table there. So my original value is 5, my new value is 6, right? So for the numerator, I want the difference. And again, normally it's new minus original, but because we haven't talked about negative values yet and the signs of numbers yet, just think of this as largest minus smallest. So 6 is larger than 5, so this is going to be 6 minus 5. The important thing is the denominator, right? It has to always be the original value. So that's 5. So this is basically going to be equal to 1, right? Fifth. And then I want to write that fraction as a percent, so I have to multiply by 100. Think of it as 100 over 1. We can simplify this a little bit. So this is going to be 20 over 1, which is 20. So this is going to be 20%. And is it increase or decrease? Well, it's going from 5 to 6, so it's an increase. I'll just do like an upward arrow to represent increase. So there's a 20% increase there when you go from 5 to 6. Okay, what about the second one, from 12 to 10? Well, again, I only care about the difference for my numerator. So for my numerator of this ratio, of this fraction, I'm going to write 12 minus 10 over the original value, which is 12. So this turns out to be basically 2 over 12, which we could write as 1/6. And then I want to write that as a percent, so I have to multiply by 100. So this is going to be, I can simplify a little bit, right? 2 goes into 6 3 times, 2 goes into 100 50 times. So this is going to be 50/3%. If you want to write it as a mixed number, you could divide this out. So 50 divided by 3, this is 1, right? Subtract, bring down the next digit. 3 into 20 is what? I guess 6, right? So that'll be 18, subtract, and that's my remainder. So another way of writing this is 16 2/3%. Now, what's going on here? Well, the original value was 12, the new value is 10. So actually, this is 16 2/3% decrease. Okay, and then the last one, let me see if I can squeeze it in over here. We start at 100, we go down to 20, so the difference is 100 minus 20 over the original value, which is 100. Okay, so this is going to be 80 over 100, which you could write as 4 over 5 if you want, if I simplify it. But then I have to rewrite that as a percent, so I need to multiply by 100 over 1. So 1/20, so this is going to be 80, right, over 1, which is 80. So in this case, it's going from 100 down to 20, so this is an 80% decrease. That would be an 80% decrease. Okay, let's look at this example. So it says, last year, a local team won 20 games. This year, it won 15 games. What was the percent decrease of games won? So it's definitely a percent decrease, right? Because the original value is 20, the new value is 15. So it's going down, right? It's going from 20 to 15. So remember, to figure this out, we have to find the difference. And for now, we're not going to say specifically new minus original. We're just going to say largest minus smallest, right, for the numerator, for the difference. So this will be 20 minus 15. But the denominator is important. We have to put the original. So originally they were at 20 games, right? So that's the original value. And then we need to convert this ratio into a percent. So first of all, I can simplify this, right? This is equal to 5 over 20, which is equal to 1/4, right? 5 goes into 5 once. 5 goes into 24 times. And if I multiply by 100 to convert it into a percent, 4 goes into 4 once, 4 goes into 100 25 times. This is going to be 25 over 1, which is 25. So it looks like it's a 25% decrease, right, in their winning rate. So going from 20 to 15 is a 25% decrease. Okay, in this example, we're told a college increased its tuition from $3,000 to $3,100. Find the percent increase. Okay, so again, we form our ratio. The numerator is going to be the difference, right? And again, we don't care which one really represents the new and the original. We just want to find the difference, and we want to make it positive. So it'll be largest minus smallest. So 3,100 minus 3,000. over the denominator is always the original value, right? It's the tuition went from 3,000, so that's the original 3,000. The new value is 3,100, so we want to divide by the original. And then I just want to make this a percent. So let me simplify this ratio first. So this is going to be what? 100. If I subtract divided by 3,000. But then that's just 100 goes into both of those, right? It goes into 100 once, goes into 3,000 30 times. And now to make that a percent, I need to multiply by 100 over 1. So again, looks like I can simplify this a little bit. This will be 10 goes into 30 3 times, 10 goes into 100 10 times. So it looks like this is going to be 10 thirds. So there'll be 10 thirds percent increase. Or if we want to write it as a mixed number, right, I can divide 10 divided by 3, convert it into a mixed number, and this is going to be what? 3 and 1/3. So 3 and 1/3% increase. Either one's fine. Just depends on what. If you want your answer in mixed number format or just in a improper fraction format. Either way is fine. Okay, what about this question? It says, of the 80 classrooms on a community college campus, 75% are equipped with whiteboards. How many classrooms have whiteboards? Okay, so if you think about this, right, we're looking for the number of classrooms, and it's going to be, we know we have a total of 80 classrooms, and we know that 75% of those, right, have whiteboards. So if we call, let me use the variable x. So this is the number of classrooms with whiteboards. That's what we're trying to find. Well, just by looking at the example, right, we know that x, the number of classrooms with whiteboards, must equal 75% of the total, which is 80. Right? 75% of 80 will give me what I want. So how do I solve this? Well, I can convert 75% into a decimal, or you could write it as a fraction, doesn't matter. But in this case, we typically use decimals when we work it out in an equation here. So this will be 0.75, right? Just move it 2 places to the left. Remember, of means multiplication, and then 80. So really all I'm doing is I'm multiplying 0.75 times 80. So if I do that over here, this is what? 0, then 40, 0, 0, 56. So 0, 0, 0, 1, 6. And I have to move the decimal place 2 places. So x is equal to 60. And really it means classrooms. So 60 classrooms have whiteboards, right? And that makes sense, right? 60 is 75% of 80. Okay, in this question we're told a quarterback completed 15 passes or 20% of his attempted passes. So 15 passes represented 20% of his attempted passes. How many of his attempted passes did he not complete? Okay, so in order to answer this, we really have to figure out the total number of attempted passes first, right? So let's give that a name. Let me call it n or something. So n is equal to the number of attempted passes. Okay, so now using that information and using n, I can set up an equation, right? We know that 15 passes represents 20% of his attempted passes. So 15 must equal, right, 20%. I can write that as 0.20 of, remember that means multiplication, his attempted passes, which is n. Right, so 15 equals 20% times n, so 0.20 times n. So now I can solve this, right? I can divide both sides by 0.20. Whatever you do one side, I do to the other side, right? I want to do that because I want to isolate the n. So n here is going to equal, let me do this out. So I need to move this 2 places. So I'm going to need to move that decimal 2. So I have to put in 2 zeros there. It's going to pop up there in the result. 20 goes into, let's see, 150, right? 7 times. So 7 times 0 is 0. 7 times 2 is 14. Then I subtract, bring down the next digit. And then 20 goes into 100 5 times. So it looks like n is equal to 75. So that's the total number of attempts, right? So 75 attempts. Okay, well now we can actually solve the problem, right? Because we're asked how many of his attempted passes did he not complete? Well, if his total number is 75, and I know that he completed 15, I can just subtract 15, right, from 75. And what's left over, in this case is 60, must be the number of passes that he did not complete. Okay? So again, let me explain that. So remember, this was the total attempts. Right? We just found that to be 75. 15 was the number that were completed. So that means the difference, what's left over, the 60 here, must be the number not completed. And that's what we were asked to find. So the answer is going to be 60. Okay, so now I want to finish off this section by solving some of your homework problems from My Open Math. So again, these are just problems that involve percents in some way or another. So this question says, Joyce paid $210 for an item at the store that was 65% of the original price. What was the original price? Okay, so what are we looking for here? We're looking for the original price, right? What was the original price? Let's give that a name, maybe P for price. And then let's see if we can translate this into an equation. So Joyce paid $210 for an item. So start with 210 at the store that was, so equaled 65% of the original price. Remember, of means multiplication. So 65% we could either write as a decimal or as a fraction, but typically we write it as a decimal. So that would be 0.65, right? I have to move it right 2 places to the left. And then of means multiplication. And in this case, I'm multiplying by the original price, which we're calling P, right? That's what we're trying to find. So it looks like that's my equation. So now I need to solve this. First of all, let me just write it the other way as 0.65p equals 210. Usually you put the constant in front of the variable, right? It's called a coefficient when you put it in front of the variable. And then how do I get p by itself? Well, I need to divide by 0.65. And whatever I do to one side, I have to do the other side, right? So that cancels. So let's do this out here. We have 210 divided by 0.65. I need to move this 2 places. That means this has to go 2 places. So my decimal point will go there. We want to round it to nearest cent, right? So I might have to go a little further. I might have to add a few more decimal places. And then let's see if we can work this out. So 65 into 210. It looks like that'll go in 3 times. Right, so 3 times 5 is 15. Carry the 1. 3 times 6 is 18 plus 1 is 19. So now I subtract. This is going to be 5, right? And then this will be 1. And then bring down the next digit, which is a 0. 65 into 150. Looks like it's twice, right? 2 times. So 2 times 5 is 10, carry the 1. 2 times 6 is 12, plus 1 is 13. I subtract, so I'm going to get 20, bring down the next digit, next 0. That'll go there, actually not there. Now 65 into 200 is again 3 times. So this is going to be 195 again, right? Let me just do it out. So this is 15, carry the 1. 3 times 6 is 18, plus 1 is 19, so 195. Subtract, this is going to be 5. Bring down the next digit, which is 0. 65 into 50 is 0, right? It doesn't go into 50. So I'm running out of room here. This is going to be 500. 65 into 500 goes in 7 times. So this will be 35 with a 3. And then 42 plus 3 is 45. So this will be 5, and then 4, and then bring down another 0. And then 65 into 450, it looks like is 6, right? I'm running out of room, but actually that's good enough because now we can round that to the nearest cent, right? So it'll be, if I want to round to the nearest cent, that's going to be the hundredths place right here. I look to the right, that's a 6, so that's got to go up, the 7 has to go up to an 8, right? So my answer is going to be $323.08. Okay, so that will be the answer. And you could check it, right? You could take 65% of that, and we better get back 210, or at least within rounding error, we better get something very close to 210. Okay, what about this question? It says, find the amount of tax and then the tax rate. Round to the nearest hundredth of a percent. So we're told that the original cost of the item is $112, and the amount that we paid, the selling price, is $130.05, so $130.05. So the tax amount must simply be the difference, right, between those two. So if I take 130, so this is going to be the tax amount. It's going to be 130.05 minus 112.00. Right? I'm going to line up decimals. 112 is a whole number, so I can put the decimal point at the end and add 2 zeros to it. So this will be 5, 0. I need to borrow, right? So that'll be 8 and then 1. So it looks like the amount, the actual tax, is going to be $18.05. So this is just 1805. Okay, now we want to find the tax rate, right? So basically, we want to find what percentage 1805 is of 112, right? So think of it here. I'll write this in words. We could say 18.05. That was our tax, right? Is what percent of the original amount, 112. Because the what percent here, this is going to be your tax rate. Does that make sense? So 1805 is what percent of 112. Okay, how do we solve this? Actually, let's do it. We'll just write it as an equation, I guess. So we have 1805 is equals what percent, I can call x, of times 112, right? So I could write this as 112x is equal to 18.05. Okay, now to solve for x, I want to divide by, I need to divide by 112. So these will cancel, right? So I need to do this out here. This might be a good time to at least check it with a calculator to make sure you didn't make any mistakes. And I'm going to have to go to several places because I want to round this to the nearest hundredth of a percent, right? That means, and this is going to be a decimal when I find this answer, so I need to move it 2 places right to convert it to a percent. So I guess I need to go to like 5 decimal places in order to answer this correctly. Okay, so let's see here. 112. It doesn't go into 18, but it will go into 180 once, right? So this is 1. So this is going to be 112. I'll subtract. So I need to borrow, right? So 10 minus 2 is 8. 7 minus 1 is 6. Bring down the next digit, which is 5. And then 112 into 685, I guess it goes in 6 times. So this will be 12, 1. 6 times 1 is 6, plus 1 is 7. And then 6 times 1 is 6. I subtract again, so this will be 3, 1. Bring down the next digit, 0. 112 into 130, that's just ones. So this is going to be 112 again. Subtract, this will be 8, 1, right? And then bring down the next digit, 0. 112 into 180 is once. So this will be 112. Subtract, so this is going to be 8, 6, 0. 112 into 680, I guess, is 6 times again. And we did that one earlier, right? 6 times 112 is what? 672. Let me just double check it. So this is 12, 1. 6 times 1 is 6, plus 1 is 7. Yep, 672. And so on, but I can stop there because now I have enough to answer my question, right? So we're finding that x is, I stopped there, so it's approximately 0.16116. But remember, if my unknown is a percent, and I write it out as an equation like this, I have to do that last one step at the end. I have to convert that decimal into a percent. So I have to either multiply by 100, which is equivalent to moving that decimal point 2 places to the right. Right? So this needs to really move 2 places to the right. So really my answer is going to be 16.116%. But then they wanted us to round it to the nearest 100th of a percent, which is this one right here. So I look to the right, that's 5 or greater, right? It's 6, so it's 5 or greater. So that 1 has to go up to a 2. So really the best answer would be x is equal to 16.12%. And that would be our answer. Okay, so the tax rate is 16.12%. Okay, and then we'll just do one more example here. This example says, identify as an increase or decrease, okay? Then find the percent of increase or decrease. If necessary, round to the nearest 10th of a percent. So they want basically as a decimal, right? Nearest 10th of a percent. So first of all, if our original amount is 170 and our new amount is 200, then since it's going from 170 to 200, it's definitely going to be a percent increase, right? So this is certainly going to be an increase just by looking at the values. So we know that. How do I figure it out? Well, remember, we form a ratio where the numerator is going to be the difference. And you don't have to worry about new minus original. Just think of it as largest minus smallest. We just want the positive difference. So that's going to be 200 minus 170. Divided by, but this is important, the denominator is always the original value. So the original value in this case is 170. Okay? And then I multiply by 100, right? I convert it into a percent by multiplying by 100 and putting the percent sign there. Okay, since we want to round to the nearest 10th of a percent, it looks like they want this as a decimal. So let's find this ratio first, this fraction first. So 200 minus 170 is what? 30 over 170. And then I'm going to have to write that as a decimal. First of all, I can simplify it, right? 10 definitely goes into both of them. So this is really 3 over 17. You can cancel the zeros. Basically, you're taking out a factor of 10 over 10. And now if I divide that out, what do I get? Let's say, do a bunch of zeros there. So 17 goes in the 31s, right? So this is 17. Subtract. So I need to borrow. This is 2. 10 minus 7 is 3. 2 minus 1 is 1. I bring down the next 0. So 17 into 130, I believe, is 7. Let's try 7. So 7 times 7 is 49. 4 there. 7 times 1 is 7 plus 4 is 11. Yeah, I think that works. Okay, subtract. So this is going to be 1, right? That's a 2 now. 2 minus 1 is 1. Bring on the next digit. So that's a 0. 17 into 110, I guess, is going to be 6. So that'll be 42. Put a 4 there. 6 times 1 is 6 plus 4 is 10. Then I subtract again. So this is what, 8. Bring down the next digit, which is a 0. 17 into 80 is 4. Well, yeah, 5 will be too big, so I guess it's 4. So this is going to be 28. 4 times 1 is 4, plus 2 is 6. Subtract, so this is 2, 1, 0. And we can keep going, but I have enough now to find, right? Remember, I want my answer to the nearest tenth of a percent. So this is a decimal now, right? It's around 0.1764. Now I have to multiply by 100 to make it a percent, right? I haven't done this part yet, right? So multiply by 100, but that's simply going to move this decimal point 2 places to the right, right? So really it's just doing this. It's moving it 2 places to the right. So this is 17.64%. But then I wanted to round it to the nearest tenth of a percent. So what digit is in the tenths place? That's the 6 here. I look to the right. I have a 4, which is less than 5. So that's going to stay a 6. And then everything else drops off, right? So the answer here is going to be 17.6%. And it's going to be an increase. So that's our answer. So 17.6%. And in this, they're going to ask you for whether it's increase or decrease. We just found it's an increase. All right, great. So hopefully that will be enough so you guys can get started on your homework. That's it for percentages. The next module is going to look at sign numbers. So now we actually will start dealing with positive and negative values, so we can handle a variety of different numbers now. Great, thanks.